Hi there, this is Jacob Nash, Engineering Lessons, and this is Unit 2.3, Lesson 1. Now, here's something to say about the last few units I do in this course for this YouTube channel. This unit, let me see here, I had a paper somewhere that said what units I'll do. Oh, here it is. So, here's the units I'm going to do. 2.3, 3.2, 4, or 4.1, and then that's the last one. So those are the only three ones I'm gonna do, but they may not have all the information that you need for your class because I'm kind of running behind on these videos, but I'm pretty busy during this time. Because I still have classes of my own right now that I'm trying to prepare for their exams as the semester ends for what it is for me. So, but anyways, I'm basically just going to be showing you how to solve the problems for these next few units instead of the very technical notes. So, this is just going to be showing you how the parts of a stress-strain graph, because that's what this unit is, stress-strain. So, in this unit, you will learn about how engineers can make a stress-strain graph and do tests to see if a material is good enough for the building that they're trying to do, whatever they're trying to build. This is important because you will see that there's a failure point, or the part where the material breaks after it's been stretched out too much. If that failure point comes too soon, then it might not be a good material to use. For example, if you try to build a house out of aluminum foil, if you try to stretch that out, it's going to rip in no time because that thing's weak. Aluminum alone probably isn't, but foil is. So, let's look at the graph. So, on the y-axis, we have stress. I accidentally had part of my hand writing and part of it on the undo button. Sorry about that. And then we have strain on the x-axis. You might be required to label this for your unit test for this unit. And now we have the line that we're going to draw. So it goes up until it gets to a certain point, goes down, has a little hump, and then goes back up until it just stops. And there's certain parts of this that we'll need to address. Now, you can see the graph is kind of moving in first a up direction and then a right direction. The section that is where it's going pretty much just up is called the elastic deformation or deformation. Sorry about my handwriting here. If any of you watching are left-handed, you know that it's very hard to write on a screen because when you're left-handed, your hand has to be on, like if you're writing on a piece of paper, your hand has to be on the paper. So people that are left-handed that have been writing a lot have a black, like their hand is like black on one side because the pencil lead's gotten all over it. But that's how it always is for me. So that's elastic deformation. And then the part where it's mostly just going to the right until it fails is called just the plastic deformation. So, that's what we have so far. Now we have some points to label. The point that's directly across at the bottom of this hump is called the proportional limit. So that's the limit of how much stress that there can be, because the stress immediately goes down and goes constant, and strain occurs. So proportional limit. Then the point that is the highest point at the hump is called the yield point. And then the last point over here is called the failure point. So the failure point is when the material would break. So think about it this way. So we have, let's just say we got some material here, and it's just kind of just like a flat cylinder shape. And there's going to be kind of like pincher things to go on it, like here and here. And first, it'll get stretched out. After it gets stretched out, it'll go into what's called a dog bone shape that kind of looks like an eye, because it's got stretched out. And then it will be stretched out this way, and then eventually it will break, and it will be like that. So first that occurs, that's when there's stress. Then there's strain, when from the point to where it's about to break, and then there's the failure point. So that is it. Well, actually, sorry, there's one more thing to label. Up here at the highest point after you get into the plastic deformation, that's called the ultimate tensile strength, or UTS. That's at the ultimate point before it fails. So that is a stress strain graph. That's what it looks like. And on the next video, we will explain how to solve some stress strain problems and the process that we will use. And that will be it for this video.